Bonjour. I almost understood the entire introduction, but I will continue in English. I'm Dror, and this is Chris. We're working together. I asked Chris to join me today as she's not just from here, she's also leading a very big effort in our office today with some of our architectural projects. We have a practice in New York City that's specialized in a lot of different things. In fact, we specialized in absolutely nothing but ideas. We specialized in projects that we bring a lot of specialists to work with us together to make them and realize them. Our project range in scale from product design to large architectural projects, master planning, urban landscaping, and creative direction. Just to have a few projects in the background that kind of shows you the diversity and the different projects that we are currently working. And it's pretty interesting because we are a group of 20 individuals, 20 very smart individuals that have a background in architecture, design, and graphic, mostly. And our consultants are ranging from structural engineers to landscapers to animators and many others that are constantly joining us on the different projects that we're adapting. We are committed to two things: innovation and improvements of well-being. And I'm very lucky to be here today and to share with you one idea that have started some years ago, in fact, in our workshop, when we accidentally played with certain geometry and certain physical parts and actually started to create what we now have our own R&D part of our practice, which constantly think about ideas that nobody, in fact, asks us to do. So it was not born from an RFP. It was not born from any brief or request of a client. And in fact, it started and continue to a point where we actually bring different ideas and share them with different people. The idea that we're going to share with you today, in fact, was born with a conversation that we had with Leticia, and she, in fact, is the one that believed that some of the things that we've done could be beneficial for construction sites. So, today is, in fact, the first time that we're going to show this idea, that we're going to show the idea in its current form. But prior to that, maybe we can speak a little bit about the condition of the sites.
So of course we've been speaking all day about construction sites, and I don't have to remind everyone what the pitfalls of construction sites are. In a few images we know and we could see that construction sites are noisy, unfriendly, dirty, inaccessible, dangerous areas of the city, and throughout the course of their life they ultimately become very prohibitive areas in our various cities. And we're all here today because this is not a small problem. In our day-to-day life in New York, countless construction sites shape the way that we experience the city. Et moi-même, étant montréalaise, je comprends directement l'impact des chantiers sur notre belle ville. But what we want to talk about here is opportunity. Instead of seeing construction sites as voids and interruptions in the urban fabric, can we instead imagine them as engaging catalysts of urban change? And this is where we present to you that idea.
So it started, as I mentioned a couple of years ago, with similar blocks to those ones that I brought today. I'm going to first just explain the geometry very quickly and then go straight into the typology that we brought today. Essentially what I have here is 4 identical blocks. They are an L-shaped pieces that if you position them one next to each other, they form a square. When you position them in such a way where 2 are next to each other, let's call it horizontally, and the 2 other ones are counter to that vertically, they can actually ride on one another. So the difference here is just that those are slightly larger and they're connected to one another. So when you position them in such a way, they're able to create a triangulation that is always parallel to one another. So the hinge is actually done by the geometry of the pieces. There's no additional components besides the wood pieces that are connected to one another. So for quite some time, we've been wondering, what can we possibly do with this? We realized that... that I'm frozen. We realize a couple of things. It's always parallel to the ground, and every side that you have a V shape, you have an A on the other side. So the triangulations are always opposite and are always crossing. So essentially supporting... Are we stuck? Oh. So there's always this ability to basically position them next to each other, on top of one another, and create this kind of wall. So we realized that basically all that we invented at that point is a new typology, is a new wall that can actually do a lot of different things. What we're going to focus today is the ability and the use of this construction methods potentially for construction barrier. Now, this is pretty much one idea, and it's a beginning of one idea that we're sharing today here with you. And of course, we know that there's a lot of different things that we need to overcome before we can actually do that. But one of the speakers before, Colin, and I'm very happy that you asked him to speak before us, was actually showing us that people are walking slower next to something that is more attractive. And I was kind of wondering, what does that mean? Does that mean that those people are actually having more fun? They're enjoying? Is that the reason why their pace is slower? Can construction site barrier do that? Can we actually think about them in such a way that they are actually beautiful elements rather than reducing slightly their ugly presence? So if we're comparing, what we're trying to do is to actually make them a very beautiful walls, which essentially is just a canvas, right? We can invite artists to do different things with them. We can actually communicate message with them. We can share what the construction is all about through a new type of wall, through a new type of structure. It's simple, it's very strong, and it's very versatile. And it can be, of course, made out of a lot of different kinds of materials and out of a lot of different kinds of proportions. And that would, of course, affect the cost, the deployability, and the reusability of this construction barrier.
I think as we could see in these examples, there is a kind of versatility and a playfulness that touches upon a lot of the topics that came up today as well. We can see that there could be a vegetated application which engages passerbys in a different way. In this image, we can imagine that there could be different perforated applications, and this is just one instance of many different possibilities where we can engage people on the sidewalk to get a different understanding of what you could see inside the construction site. And of course, as we would like to develop this, they would be reusable and adaptable depending on the different materials in which we explore them in and in which they are made. So they could have a variety of uses, and their lifespan could be a very big plus for their application.
One of the things that we also looked at, and this is of course in collaborations with different engineers, we actually had quite a lot of conversation with the ERUP team in New York that actually point a very interesting fact. Can those barriers improve the sound? Can those barriers actually reduce the sound from construction site? And this is something that, as an assumption, because of the geometry, it seems to be the case. I think that in the previous presentation we've seen just one angled piece on top and the reduction of noise here. This is definitely something that we are very much interested in investigating and checking further when we're actually making them. And in fact, the deployability is something quite interesting. The scale of those units is quite thin. Of course, depending on what material we're using, but if we're envisioning the same type of construction barriers, which are painted plywood, the thickness is approximately the same thickness that you're seeing here, and the ability to deploy quite a lot of them very inexpensively and very quickly is a major factor.
And one other point to make here, as you're seeing in the slide, is that our main, almost our comparative point was the traditional Jersey barrier, which everyone is familiar with and we can see. So in terms of size and scalability, there is already an ability with the Quadror to have something that is familiar to the construction site in a very unfamiliar way that has a lot of potential for different uses.
So we've been actually trying all kinds of different construction methods and all kinds of connection possibilities. Of course, it depends on how this is going to be made, whether it's sheet of metal or wood. In this particular diagram, you can see that we're actually using two parts, a component that attach the pieces to one another, and the component themselves, which are made out of 4 identical pieces. And of course, because of the repetition, the ease of manufacturing is quite obvious. And then to the next steps. So of course, I know that there will be questions about costs, and that's going to be kind of the main things to land. It's a direct relationship to the material that we're using, the proportion that we're using, the production methods, which is part of course, the material and the assembly technique that we're going to be ending up using. And we just created a couple of visualizations to show the potential aesthetic of those kind of barriers. This is in fact the project that we're doing in Turkey right now, and this is also a proposal that we're making for that project. It's 1.2 kilometer of Bosphorus front, which essentially is going to be a construction site for the duration of the next 4 years. So in this case, we're proposing to actually use acrylic sheets, colored acrylic sheets that will be, of course, a lot more expensive than plywood, but with the right setup, with the right sponsorship, with the right cause, this can be done. And this is another example, actually in Miami, New York. Thank you.